Okay, so let's look at question 2, which is a structured question containing 10 marks, and it had two parts, part A and part B. So each of these two parts are carrying 5 marks. So part A is saying for the equation P is equal to BV plus AX plus Z, where P is equal to pressure, V is equal to velocity, and X is equal to length, find the dimensions of the expression Z over AB. Find the dimensions of the expression Z over AB. So how are we going to deal with this question? This question is coming from, it's also the first unit, units and measurements. This is dimensional analysis. And I remember explaining dimensional analysis very well, very, very well, such that it would be very difficult for someone to fail a question. So this is what we're going to do. They've given us an equation to say P is equal to BV plus AX plus Z. So in order for us to find the dimensions of this equation, we're supposed to find the individual dimensions of Z, A, and B. Then we'll deal with those to find the overall dimensions of this equation that they've given us there. So how are we going to find those? It's firstly by using this same equation that we've been given here. We know to say this guy, which is on the left hand side here, is pressure, and they've given us to say pressure is equal to PV plus AX plus plus Z. So this B here, this A here, and this Z, these guys are constants. So we're supposed to find the dimensions of those constants and use them here in this equation that we've been given there at the end. And how are we going to do that? First, let's find the dimensions of pressure. Let's find the dimensions of pressure. Where's my board? Here. So this is the equation we're using. P is equal to BV plus AX plus Z. So this is the equation we're using. So we know to say pressure is equal to what? Pressure is equal to force over area. And what are the dimensions of force? Force is equal to mass multiplied by acceleration. That's the equation for force. Whilst the area is just area like that. This is a derived quantity, area. Then mass times acceleration is equal to what? What are the dimensions of mass? The dimensions of mass here, I'm going to use kg. So the dimensions of mass are kg, and they are multiplying by what? They're multiplying by the dimensions of acceleration. What are the dimensions for acceleration? We are saying it is meter multiplied by what? Multiplied by second squared, like that. That's what we are saying on meter. So on acceleration. So that is going to be equal to multiplied by mass, meters multiplied by second to the power -2, like that. That is the value of acceleration. And this is dividing by what? This is dividing by the guy area squared. And what are the SI units for area squared? It is meter squared, like that. Okay, so the meter squared, this meter here will cancel out with one of the m's there, which means we are going to remain with 1m in this equation. So how is our new equation going to be? If we cancel out those guys, how is our equation now going to be? So it is going to be kg. Then what else do we have? We have meter here down. But the meter that we have, remember, it's a denominator. So we are going to denote it using a minus sign. So I'll put a dot m for the meter, -1. Since here we canceled out 1, which means we're remaining with 1 down here. But it's a denominator, so it's -1. Then what else are we having? We're having second, which is the SI unit for time here. So we have our second, which is the SI unit for time. And what is the value of, or what is the power to this second? It is negative 2 like that. Okay, so that is what we're going to have. And these are the dimensions for what? These are the dimensions for pressure. Yes, have I made any mistake? I don't think so. Mass, kilogram. Now we have meter for length there. And I have m to the power minus 2. Okay, it's a squared. Okay, so those are the dimensions for pressure. Now, what are we going to have? We're going to see that this pressure has been equated to these individual uh, uh, expressions on the right-hand side. And what does that mean? When you are dealing with dimension analysis and they've given us to say the something on the left is equated to such an equation on the right, that means you have to equate P, which is on the right, to the individual expressions on the right. That means P is equal to BV, P is equal to AX, and P is equal to Z. That's how we go about it when we're dealing with the dimensional analysis. So if that is the case, how are we going to find the dimensions of B? We're going to say P is equal to BV. What have we gotten? We've only gotten the first part of our expression here, which is BV. And we'll do the same to AX and we'll do the same to Z, because our goal is to find the dimensions of B, A, and Z. So if this is the case, let's make our B the subject of the formula. We are dividing both sides by V. That means B is equal to what? B is equal to P over V. And V here is velocity, so that means B is equal to the dimensions of pressure. We are from finding to 6 kg, m power minus 1, s power minus 2. So we have kg m minus 1, s minus 2 over velocity. What are the dimensions for velocity? It is meter multiplied by what? Meter per second, which means it's like that. Okay, so some values may cancel out here. And if they cancel out, what are you going to remain with? You can see that to say S here is cancelling out, or power minus 1 here will cancel out with one of those. That means we're remaining with 1. Then what else are we having? Okay, so this, since here is power minus 1, that means these guys are going to multiply. This is a denominator, which is having a positive power. This one is having a negative power. That means it is going to be negative 2. Okay, so that means our values of B, or the dimensions of B, are going to be kg. The m here will now be power 2, this and this. Then what else? It's our s here. It has remained power minus 1, since it has cancelled out with one of those. That means these are the dimensions of our B there. Okay, then let's go back to the dimensions of AX. So we're going to use the same approach. We're going to say P is equal to AX. And if P is equal to AX, we're dividing both sides by X, which is just distance, for us to get the dimensions of A. So A is also going to be what? To be equal to P over X, like that. Okay, so A will be equal to P over X. And what is P? P is equal to kg m power minus 1 s power minus 2 over, what are the dimensions of X? X, they've given us to say this is just length. And since that is just length, that means we're dividing with only the meter here, down here. And if we divide with that, what are we going to have? We're going to have kg multiplied by m power minus 2 multiplied by what? Multiplied by s power 2, like that. So that means our A is equal to this guy here. Okay, then PZ is just a constant. That means P is equal to Z. And since P is equal to Z, that means it is also equal to kg multiplied by the distance, power minus 1, multiplied by the second, power minus 2, like this. Okay, since now we have such kind of an equation, that's now when we can come back to our Z over A, B, which we've been asked initially in the question. Z over A multiplied by B. Okay, so if we get that, that means we'll have our kg meter power minus 1 second power minus 2 over, what was our value of A? A is equal to kg meter power minus 1 second power minus 2. Now I'm wondering how A, oh no, A is kg, okay. So it is kg meter power minus 2 s power minus 2 multiplied by, what were the dimensions of B? B was equal to kg meter power minus 2 second power minus 1. Kg meter power minus 2 second power minus 1. So we can now manipulate these guys in order to find the final dimensions of our equation. So I'll say Z AB will be equal to, what are we going to remain with here? So kg here can cancel out with that kg there. Then what else? Second here can cancel out with this one, which is here. Then what else? Have meter here. One of them will cancel out with the one which is here. So which means we're remaining with the m power minus 1 there. And if we have such an equation, all of the ones which are on top have cancelled out. That means we're going to remain with what? We're going to remain with kg here. Kg multiplied by what? Multiplied by meter power minus 2 or power minus 3, since there is also this one here. So meter power minus 3 multiplied by what? Multiplied by second power minus 1. That means those are the dimensions of our equation. Okay, so that was part A of question 2. We can now go to part B.